Okay, 100 trig identities. Let's go. Number 1. Here we have sine square x times cosecant x times secant x. And the usual strategy for this is that let's just work with sines and cosines. So I'm going to first keep the sine square x. But for the cosecant x, we will have to remember that's equal to 1 over sine x. So we will make a change. And remember, they are multiplying. And then for the secant x, that's equal to 1 over cosine x. So again, let's make the change. Then we can see that we have this sine x on the bottom. We can cancel with one of the sine x right here. So that becomes sine to the first power. And then we just have to multiply sine x with 1 over cosine x. And that will just give us sine x over cosine x. And what's that? Well, if you say tangent, then you are correct. That is the answer. That's it. Number 2, we are looking at sine x times cosine x times tangent x. Let's do the same thing. I'm just going to keep the sine x and the cosine x, but we are going to change the tangent x into sine x over cosine x. And remember, they are all multiplying. Now, we have the cosine x and the cosine x, they can be cancelled. And then we can see we will multiply the sine x and the sine x, so that becomes sine square x. And I'm just going to write the square right here. And we are done. Number 3, we're looking at tangent x times cosecant x. Tangent x is the same as sine x over cosine x. And cosecant x is equal to 1 over sine x. And here, sine x and sine x can cancel. And we have 1 over cosine x. And what's the answer for that? Well, we can write that as secant x. Yes, and that will do it. Pretty fun so far, right? Now, let's take a look at number 4. We have a fraction to begin with. We have a secant x minus a cosine x and then over a sine x. So what do we do? Let's just go ahead and try the same thing. I'm just going to rewrite the secant x as 1 over cosine x. And then minus the cosine x, just keep it. And then over, on the bottom we have the sine x, just keep it. Notice here we have a small fraction instead of a big fraction. And this is what we call a complex fraction. And to simplify a complex fraction, we can try the following. Let's just go ahead and multiply the top and the bottom by the lowest common denominator of the small fractions. Since we only have 1, so we just need to multiply this by the cosine x right here. Top and bottom. Now, take this cosine x, distribute it, just multiply. Cosine x times 1 over cosine x, that will just be 1. And then minus cosine x times cosine x, that's cosine square x. And on the bottom, we have sine x times cosine x. So far so good, but what can we do to continue though? Here, this is the identity that you really have to know. So let me pick down a note for you guys. This is the Pythagorean identity, which says sine square x plus cosine square x is equal to 1. And you should also know its variations, because right here we have this what? 1 minus cosine squared, right? So if you look at this equation here and minus cosine squared to both sides, then you can see on the left hand side we get sine square x. And that's equal to 1 minus cosine squared. And that's exactly what we have on the top right here. We can put that as sine square x. So that is equal to sine square x on the top over sine x times cosine x. Then we can cancel this sine x with one of them on the top. So the top is sine x and then the bottom is cosine x. And of course, we can write this as tangent x, and then we are done. Number 5. Here we have cotangent x over, on the bottom we have cosecant x minus sin x. And let's do the same thing. For cotangent x, that's equal to cosine x over sin x. And these are the identities that you really have to remember by heart. And you have to know them really well. And then continue. Over cosecant x, that's equal to 1 over sin x. And then minus the sin x. Now, we have complex fractions again. This time, we just need to multiply by sin x, the lowest common denominator of the small fractions. They are the same, so sin x will do it. And then, because the bottom we have 2 terms, make sure you put parentheses around it and multiply by sin x. Sin x and sin x cancel, so the top is just going to be cosine x. And then the bottom, let's distribute sin x. This times this will just be 1. And then minus this times this will be sine square x. Okay, how can we continue from here? Well, if you look at the bottom, we have 1 minus sine square x, right? That is very similar to what we just went over earlier. Remember the Pythagorean identity and also its variations. When we have 1 minus sine square x, that will give us cosine square x. So I'm just going to write that right here. And then once again, we can cancel, and we will just have cosine to the first power x on the bottom. And 1 over cosine x will give us secant x, and then we are done. Just like that. Number 6. Here we have 1 plus 2 cosine x over 2 sin x plus tangent x. Okay, we do have the tangent x. Let's just rewrite that. So keep the rest first. For the tangent x, write that as sin x over cosine x. And we would just need to multiply the top and bottom by cosine x because that's the denominator right there. Again, put a parenthesis around the top and also around the bottom because they have 2 terms. So multiply by cosine x and also multiply this by cosine x. Okay, here is the deal. I am not going to multiply out the top. You guys will see it. But I'm just going to write it as cosine x times parentheses 1 plus 2 cosine x. And then for the bottom, I will multiply out the cosine x here and here. So we first have 2 sin x, and then cosine x, and then plus, they multiply, the cosine x will cancel, it's just sin x. Now, why didn't I multiply out the cosine x from the top? Because notice the bottom, what do we have in common? We have the sin x and sin x here, right? So we can factor that out. Have a look. Keep the top. And then factor out the sin x. And we will have 2 cosine x from the first term right here. And then remember, this originally is plus sin x, but we took out the sin x already. We still have a plus 1. Now, do we see it? Hopefully we do. Have a look. On the top here, this is 1 plus 2 cosine x. On the bottom here, this is 2 cosine x plus 1. The order of addition doesn't matter, so they are really the same thing. So we can cancel them out. And we have cosine x over sin x, which becomes what? Cotangent x, and we're done. Just like that. Number 7. We're looking at 1 plus cotangent square x. Okay, 1 is 1, but cotangent is cosine over sine, and this is to the second power, so let's just make sure we have cosine square x over sine square x. Okay, what can we do next though? Well, we're adding a fraction, right? This is 1 plus a fraction. So why don't we get the common denominator and then just combine the fractions? So let me move this a little bit. For the 1, that's the same as 1 over 1. And I will need to multiply this by the sine square x. So they will have the same denominator, and of course, we do the same thing to the top as well. Okay, so to continue, both of them have the same denominator, namely sine square x already, so let's write that down. And for the top, 1 times sine squared is just sine squared x plus this, which is cosine square x. Have a look. This is the Pythagorean identity again. Sine square x plus cosine square x is just nicely equal to 1. So we are looking at 1 over sine square x. Well, 1 over sine is cosecant, and this is to a second power, so altogether that's just cosecant square x. And that's it. Number 8. We are looking at cosine x plus tangent x times sine x. Okay, tangent, let's just fix that. So here we're looking at cosine x plus sine x over cosine x times sine x. So we can multiply the sine x together. That will give us sine square x. So put a square right here and then over cosine x. Now notice I left a space right here on purpose because again we can kind of complex the fractions. Cosine x is like cosine x over 1. Here I need to multiply by this cosine x. I need that on the bottom. And that's also do the same thing to the top. So we see the top is just cosine x times cosine x, which is cosine square x plus sine square x. They have the same denominator, so we can just put them together in one fraction. Well, cosine square x plus sine square x. The order of addition doesn't matter, so this is equal to 1 as well. So we have 1 over cosine x, and that's equal to just secant x. That's it. Number 9. Here we have sine x minus sine x times cosine square x. We don't really have anything to work with, right? Because everything's in terms of sine and cosines already. But notice we have a subtraction, and the first term has a sine x, and the second term also has a sine x. So what can we usually do? Well, we can factor that out, right? Just like in our algebra class. So let's factor out the sine x. So we took out the sine x, the first term will be a 1. And then minus the second term, we just have the cosine square x left. Just like this. And you see that here we have the sine x, but notice that 1 minus cosine square x is sine square x. Sine x times sine square x, the first power with the second power, add the exponents together, that will give us the third power, sine to the third power x. Okay, number 10. We have secant x minus cosine x over tangent square x. And here we go. For secant x, let's write it as 1 over cosine x, and then keep the minus cosine x, and then this is over tangent square x. It's the same as sine square x over cosine square x. So once again, we have a complex fraction, but be careful this time because this is cosine to the first power and this is cosine to the second power. We have to get the lowest common multiple of the denominators. So we will have to pick the one with the higher exponent. So we multiply the top and bottom by cosine square x. And let's just go ahead and distribute cosine square x over cosine x. One of the cosines will cancel, so we just have cosine to the first power. And then cosine square x times cosine x, that will be cosine to the third power, x. And on the bottom, we see that this and that cancel, so that's just over sine square x. So far, so good. Okay, but what can we do to continue though? Well, notice that here we have cosine to the first power, and this is cosine to the third power, right? So in fact, we can factor out one of the cosines. So we can write cosine x, and then that will be times 1 minus, it was the third power, but we took out one of them already, so that would be cosine square x, like this. And then over sine square x. And that's just by factoring out the cosine x. Now, as you guys notice, 1 minus cosine square x, that's again sine square x. So let me write that. And then this is over sine square x. And this is so nice because they cancel out completely, and the answer is just cosine x. And we are done.